So we're deriving elementary integration formulas. Next up is Simpson's rule. We can get Simpson's rule by combining our midpoint and trapezoidal rule. So remember, the midpoint rule for the integral from 0 to h f of x dx was h times f of h over 2. And then we have these two error terms, one proportional to h cubed, and then the next order is proportional to h to the fifth. The trapezoidal rule for the integral from 0 to h f of x dx used h over 2 times f of 0 plus f of h. And again, we calculated the error terms, the first one proportional to h cubed, and the next one h to the fifth. So if we look at this, we see that we can combine the midpoint and the trapezoidal rules to get a new rule where we can cancel the h cubed error term. So we can get a rule that has a higher order error term. That means that the error for a given h, the error should be less for Simpson's rule. So let's combine them. So we have a h cubed over 24 and a minus h cubed over 12. So if we multiply the midpoint rule by 2 and add it to the trapezoidal rule, we'll get 3 times ih. And then we're adding this one plus twice this one. So we have h over 2 f of 0 plus f of h plus 2h f of h over 2, right? And then the h cubed cancels. And we have the error term here, which will be twice this one. So 2 over 1920 minus this one, minus 1 over 480, whatever that is, times h to the fifth times the fourth derivative of f at h over 2. Okay? This is the error term. So the error term is big O of h to the fifth. So we can combine these things. So we get, for the trapezoidal rule, we get I sub h. We combine these so we can factor out we divide through by 3, and we have a half, so we can have a 1/6 here. So we have an h over 6. And then what do we have left? We have an f of 0. Right? And then we have a 2 here, and then a division by 2, so that would be 4. So plus 4 f of h over 2 plus f of h. And then the error term here is big O of h to the fifth. Okay? That's Simpson's rule. It's usually not written like that, so let me write it in more standard form. The usual way of writing it is the integral from, instead of 0 to h, it's the integral from 0 to 2h. And then we multiply h by 2, so then you would see it as h over 3 times f of 0 plus 4 f of h plus f of 2h. And then the error term is still h to the fifth. So that's the famous Simpson's rule. So this is remember, very important, this is the integral from 0 to 2h of f of x dx. Okay, so let me summarize these elementary formulas. We've derived 3 of them: the midpoint rule, the trapezoidal rule, and Simpson's rule. The midpoint rule and the trapezoidal rule have the same order of error, big O of h cubed, when you integrate from 0 to h. But the difference is the midpoint rule takes the value of f at the midpoint of the interval, and the trapezoidal rule takes the value of f at the two endpoints of the interval. Combining both the midpoint rule and the trapezoidal rule, we can get Simpson's rule, then, which takes the value of f at both at the two ends of the interval and at the middle of the interval. Usually you write it, Simpson's rule, as an integral from 0 to 2h of f of x dx. Okay, now with these elementary formulas, we can look at integrating a function over an arbitrary interval, say the integral from a to b of f of x dx. I'm Jeff Chasnoff. Thanks for watching, and I'll see you in the next video.